Okay, everyone, it's late, but it's worth it. I'm going to record my first demo and start to give a tour of my local AI system from one end to the other. So the first thing I want to show you is the service dashboard. Every tile here is a different service. I made this program because I want to run everything on one GPU, and that means sometimes I need to stop one program to free up VRAM and start another one. So if I want to run a specific different service, let's say I want to fire up this large language model, what it should do is it should modify two services as it told me here. And if you notice from the other tile, it turned gray. It decided that Modern BERT was using up the most VRAM and killed it to start Quen, which you also saw. It refreshed and saw that it loaded. So it'll essentially automatically load the different services that you request. I can request them with the start and shutdown buttons here, but the real good way to call them is with the OpenAI proxy. But the OpenAI API format is really popular now for large language models. But I've taken all of the services that I could find on OpenAI's API that I'm also running locally and expose them behind a single API endpoint. So if you request a different language model, it'll stop models that are using up VRAM and start the one you requested to make that response. So if you're willing to endure the latency, it's like a single server that provides an entire OpenAI style API. Hey, Editor John here. I wanted to add a thing about my OpenAI proxy. So I'm able to just add specifying the model to one endpoint. And every time you make a request for a different model, Dispatcher will automatically find whatever is using up the VRAM and kill it and start something else. The good thing about this is if you pick your models in a way that they'll all actually fit in VRAM, then they will just sort of get into the groove and everything will stay loaded and you can run the different things you request. But in this case, like responses 0 would be the fee request, and it looks like it made a bunch of arachnophobia jokes. Looks like Quen made a pithy one-liner, but I wanted to specifically show off the response from DeepSeek distilled model. So we have the content field, which is going to show, that's the regular answer it would come up with. I mean, the other thing we have is a model reasoning field. One thing I've done in my API proxy is if there is a think block in the response a model generates, it will actually move that into a separate model reasoning field. The reason I did that is because I couldn't figure out in DSPy how to make the system handle reasoning models correctly. If a model is performing reasoning, you're supposed to remove that before you send it back to the model for an additional response. And you're already getting the benefit of that reasoning just by having the tokens and context. So I'm returning from my proxy requests that are just already ready to use with tools that aren't reasoning aware, which I think is cool. Now, the other thing I'm really focused on is tool execution. So this is essentially a RAG-based implementation of function calling. I don't want to have to specifically know the functions beforehand to provide to the language model. So I've made a system where they can be embedded as text documents inside a regular vector database. So this is like an example tool. They should be really short and sweet. I want them to be kind of less error prone and more of a building block of a program. There's the code, and what it basically does is it gets an embedding, and it uses that to search for documents that have a similar embedding. So I do have a little tool running front end here that I have a result loaded up. So it shows the code on the left side and it shows the arguments that it requests on the right side. I've basically been asking large language models to fill out those arguments and run the results to get things out of these tools. But this one specifically searches the database. So if we look for the query next slide, we'll get results that are, well, whatever the tool prints out and whatever the tool has in its environment when it's done. It's all based on Python's exec command. So I'm loading variables into it when it starts, and I can pull those variables back out when it's over. And I'm also capturing the standard output. So to interact with a tool, all you have to do is use a print statement, and any text you print out is available at the end of the run, and any variables that you made are available to whichever system called it. So in this case, the semantic search, we really want like document IDs ordered by the semantic similarity, and just showing this particular tool here, we searched for the query of next slide, and we found an exact match of a tool whose text says next slide. The code is actually inside structured content, so that's truncated here, but if we pulled up that tool, we could see the entire contents of it. But by searching for this phrase, we found this tool, and that includes an input description, which should give a language model all the information it needs to A, find a tool based on some search query, and B, provide all the parameters it needs to execute it. Here's another tool, which is quite a bit larger, and I'm calling this one a workflow. And workflows have a specific signature, which is related to incoming events. This is a little bit messy, but in truth, it's really for the machines to read, not us. But Dispatcher also includes a service for Telegram. The way that works is this service doesn't actually require any VRAM, but it does allow the service to talk to the dispatcher when it registers itself. And one of the things it's doing there is making itself available as a portal. So in this case, the Telegram service is running around the clock listening for messages from Telegram. And when it receives one, it's going to put it into the dispatcher and send it to a workflow. So what we expect is that we're going to have some kind of event that we can reply to, and a query, which is maybe not the exact right term, but whatever the user sent over Telegram, and some other stuff. The main purpose of this workflow is to classify a query, which I'm doing with DSPy, and then also make some other decisions about the query to send it to a different workflow, which should be a little more specific, focused on like retrieving information or executing some tools or doing some different thing. That's one way to look at it. And now I'm going to pull up my terminal, and here is a screen share from my phone. What I'm going to do now is I'm going to send a message to the system through Telegram, and I might be able to say, well, I think it's actually configured for the audio version. So let me just try to do end to end, and we'll see what Dispatcher does in the terminal here. Hello again, Next Day Editor John here, and I wanted to record a better view of the end-to-end audio workflow. So, and not put the wrong things on screen with standard out. So let's just have a look at all the tools working together, and just kind of have a look at the dashboard as it flashes and blinks through the different jobs it's going to do. I have a screen share up on my phone here. So let's ask it a question and try to get it to fetch some news for us. Have any celebrities passed away recently? And what that should do now is startup, where's Whisper? Yep, startup Whisper. That's going to get a transcription. That transcription should come back over Telegram as soon as it's ready. And from here, the audio workflow basically calls the same workflow that typing a text message would have called. So it looks like, yeah, it killed a language model there. It's probably started up a different one to do whatever the internal workflow for text responses does. I think the first thing it should do is classify some stuff. And once it picks what kind of response it would be, this one's obviously information retrieval. It calls a specific info workflow. And that workflow generates the responses but doesn't send it. In this case, I've asked the audio workflow to put things out in text form so I can debug it and see what's going on, but only create audio of the answer portion. The citations are left out, although it looks like it did it inline them? No. So let's have a listen to the Piper output.
Yes, several celebrities have passed away recently. Notable figures include actor John Hackman, actress Michelle Trachtenberg, R&B legend Roberta Flack, who died on February 24 at the age of 88 due to cardiac arrest after a multi-year battle with ALS, and director David Lynch.
So, rest in peace to those folks, but I needed something to pull from the news, and yeah, we're actually getting search results. The AI is not complaining that its information is out of date, and I have a complete end-to-end system that I can talk to and listen to and actually use these models. There's so many different places I could go from here. Like, it's not even really reading the chat history at all for what it's processing, but you know, it's what happens when you overhaul things. You make some dust, you break some things, and I think I had better chatting capability of just like texting back and forth and getting reasonable results back about the context of the conversation. But you know, there's a chat GPT for that. I have a terminal version of the same models. For the end-to-end thing, I really wanted to see it use some different tools and demonstrate results on that. And I'll try to squeeze in some more demos here, but basically I'm running out of time, and I think this is the most tangible thing that the system does at this point. But if that was inspiring, if you like the look of this thing, then give me a shout, and love to talk more about it. Love to take some requests and try to help you guys build your own stuff to do the same thing. So thanks for watching, and I will see you when I see you.